Hello everyone, myself Mugilan from K.S.Rangasamy College of Technology. In this video, we are going to discuss about the relationship between pixels, its fundamentals of image processing. So the basic relationship of pixels, here the picture uh, shown here is the 3x3 matrix. The center pixel is the x comma y, and the neighbor pixels are adjacent to the center pixel in both the x direction and y direction. So this is the indexing method of representing a pixel. That is x comma y is the center pixel, and that is x minus 1 comma y, and this is x plus 1 comma y, and this is x comma y minus 1, and this is x comma y plus 1. These are horizontally and vertically neighbor pixels, and the diagonal neighbor pixels are x minus 1 y minus 1 and x plus 1 y minus 1, and here the x minus 1 y plus 1, x plus 1 and y plus 1. These are the horizontal and the vertical neighborhood pixels. So here the neighborhood relation used to tell adjacent pixels. It is used for analyzing regions. So here the four neighbors of pixels, that is represented by n4 of p, that is x minus 1 comma y, x plus 1 comma y, x comma y minus 1 and x comma y plus 1. The horizontal and vertical neighbors of pixel can be represented as four neighborhood relation. It implies n4 of p or n4 of q. So next is the diagonal neighbors of pixel. Diagonal of neighbors of pixels can be represented by n d of p. So the diagonal pixels, that is x minus 1 comma y minus 1, x plus 1 comma y minus 1 and x plus 1 comma y plus 1. Here x plus 1 comma y plus 1. These are the diagonal neighbors of a pixel. Here represented both horizontal vertical neighbors and the diagonal neighbors of pixels, that can be represented as n8 of p. So connectivity, there are four connectivities, there are 8 connectivity, and the mixed mode connectivity is also there. So the four connectivities represent the n4 of p, and the 8 connectivities represented as n8 of p, and the mixed connectivity is the intersection of n4 and a diagonal and vertical neighbors of pixels. That can be in the same class range. For example, intensity are similar to each other, pixels are grouped together. So next one is the adjacency. So the adjacency can be represented as the pixel connected with the two image subsets. So adjacent together, that is the subsets here displayed S1 and S2. The same set of signals can be pixels can be grouped. We can define as the adjacency, 4 adjacency and 8 adjacency or emergency, depending on the type of connectivity. So the next basic term is path. The similar intensity level or similar brightness level of pixels are connected together to form a path between P and Q, is known as a path. So next one is a 8 path and a M path, that is 4 path. If diagonal pixels group together, or the mixed pixels, diagonal or vertical pixels connected together, we can call as a 8 path and M path. So here the term distance, so distance between the two pixels or two coordinates, um, that is d of p comma q, is represented here. So the equivalent distance can be represented, that is dE of P comma Q equal to square root of x minus s whole square plus y minus t whole squared. The pixel P comma Q with Z with coordinates x comma y, s comma t and u v. The distance is a function of metric. So the distance between the two pixels can be connected here. And next is the uh, um, pixels with d4 of p, that is the horizontal and the vertical neighbors can be represented here as 1 1 1 1, and the diagonal pixels are represented by 2 2 2 2. So the nearby is 1 and another the 2. This is represented by d4 of p comma q equal to x minus s plus y minus t mod of a minus t. So the d8 distance, that is chessboard distance, is defined as d8 of p comma q equal to max of mod x minus s comma y minus t. Here the diagonal and vertical pixels are represented as 1, and all uh, other pixels here is represented as 2. That is pixel with d8 of p equal to 1 and 8 neighbors of pixels. So next, what is mean by border the contour pixels? There can be border pixels uh, is region or a subset of points that are adjacent to points in the complement of R. It can be grouped in the inner border or outer border. The pixels having intensity that is can be large intensity having the object, and the lighter intensity we can call it as a background. So the picture shown here is the Moir pattern effect, the special case of sampling. So the two kinds of intensities represented in this pixel. And here the spatial frequency and the contrast is represented here. In this picture, the higher spatial frequency is represented in the x-axis, and the less contrast is represented in the y-axis. So the contrast and the spatial frequency both is represented in the same picture. And next is the difference in brightness with the different images. So the picture shown here having the 5% differences between the each pixels. That's all about the pixels and the neighbors of pixels. Thank you.